In this video, we're going to consider some of the UML diagrams that we might need when designing our enterprise applications. Let's think a little bit about software design first of all. One of the powerful concepts of software design is abstraction, and it allows us to focus on the essential characteristics and filter out the unnecessary distractions. But what is essential and what is unnecessary depends entirely upon the person's point of view. Consider this unfortunate feline in the picture. If you're the owner and you love your cat and you love to overfeed it, then all you're interested in is stroking it and feeding it, keeping it happy, keeping it on your side. On the other hand, if you're the veterinary surgeon who has to minister to this poor animal, you're going to be much more interested in the details, the internal workings. And this illustrates very well the idea of abstraction. It's either a furry, cuddly animal, or it's a collection of bones and organs. When we describe software in words, we can find that there are some problems. Too much detail, not enough detail, ambiguous natural language, synonyms, which are often very confusing. Diagrams often do not have the same kind of problems. In diagrams, we can provide the right kind of focus at the right time, leaving detail out until we actually need it. And the Unified Modeling Language, otherwise known as the UML, is the industry standard notation for describing object-oriented software applications using diagrams. There are 14 kinds of diagrams, each with its own focus. We're not going to look at all 14 of these, but you can see from this image that they are categorized broadly into structural diagrams and behavioral diagrams. Structural diagrams describe the structure of the application in terms of classes and components and relationships between those components. Behavioral diagrams are much more focused on the interaction between elements in the system. The UML diagrams that we're going to use for this module are use case, activity, class, and sequence. In the use case diagrams, we describe the functionality that a user wants from the system, and we'll have one such diagram for the entire application. Activity diagrams allow us to describe the activities of a given use case, and so there will be one per use case. The class diagram describes the structure of the object-oriented solution, again one per application. And then the sequence diagram will describe the behavior in terms of method calls of our solution, and it will show which methods call what other methods in the various objects within the application. And there will be one of these diagrams per use case. When we focus on the problem domain, we will use the use case diagram and the activity diagrams to describe the problem in fairly abstract terms. When we want to focus on the solution, we will use class diagrams and sequence diagrams. In a UML use case diagram, we have actors, which are entities that interact with the system, and use cases, which are what the actors want the system to do for them. Actors can be people, or they can be roles that people play, or indeed they can be other systems. And the use cases are complete flows of activity described from the point of view of the actor, and it's something that will be useful to the actor. So we can have multiple actors and we can have many use cases. And you'll see here that there are lines of association to indicate which actor will want to perform the various use cases. Now, the name of the use case can sometimes be a little bit tricky to work out. What am I going to call this use case? Well, I find that the easiest way is to complete the sentence, the actor wants to, and then describe what they want to do with the system. So we could have the student wants to enroll on an award. the student wants to register for a module. The lecturer wants to view attendance. The student wants to view attendance, and you can see that there are two lines of association to that use case. But what the lecturer sees and what the student sees might be quite different. So there is an argument for actually making this two different use cases. There are other details that we can put into this diagram, but for the purposes of our module, that's probably enough. The thing about a use case diagram is it is very abstract. That's it. 3 words in a use case, 2 words in a use case, and that, with the best will in the world, does not convey very much detail. And so it is highly abstract. But that's okay at this stage. We will need to provide more detail. For example, when I activate a use case, what am I going to do in that use case? We could use a textual description, but as we noted previously, text can be a bit of a problem. Or we could use a diagram, and the UML provides an activity diagram that will allow us to describe a use case. Now, in an activity diagram, we have got a set of actions, and we indicate the order in which those actions are performed. And what I find quite useful when identifying the actions is to assume that there is no computer in the world, which helps to keep me in the problem domain. If there is no computer, then you don't talk about a database, you don't talk about input and output, and that allows you to focus on the actual activity rather than the mechanism by which that activity is done. An activity diagram has got action nodes and control nodes, and we'll look at these in a few moments. An action node has exactly one flow in and one flow out, and control nodes can either be initial and final nodes or decisions and merge. Here's an example. We want to view registered students. Now, this is the name of the use case, and that comes directly from the use case diagram. This symbol is the activity's initial node, and this double concentric circle is the activity's final node. And in this particular use case, we've got one action. Now, we might be tempted to say, input the command to register students, then get the registered students, and then output or display the student details. But these inputs and outputs are in the solution, not in the problem. So if we can filter out computers while we're thinking about the problem area, then we can really focus in on the actual activity rather than the way the activity is done. So we're going to get the registered students rather than go to the database and extract this information and display it on the screen and so on. This is a lot purer. We're focusing only on the what, not the how. Here's another example. We want to register for a module. The first activity is to find the module. Notice that this could be implemented in a solution in all kinds of ways. But remember, the activity diagram is helping us to describe the problem area, not the solution domain. So we forget about whether there's a filing cabinet or a database or some other storage mechanism. We just say, I want to find the module. That's the what. Going to the database or to the filing cabinet is the how, and we don't describe how in this diagram. Now, find module is going to result in a decision. Either we find it or we don't. And so after this action, we're in a position to make a decision. And so this is a decision node, and every decision node has a corresponding merge node. You can see that the decision has one route in and multiple routes out, whereas the merge is the other way around. There are multiple routes in and only one route out. Now, in this decision node, there are 2 possible outcomes, and we label the paths out with these guard conditions. In other words, conditions. When we find a module, we either find it or we don't. If we find it, then we will add the student to the module. How is not relevant at this point. The what is very relevant, and we are describing what, not how, in these diagrams. So we read this activity diagram by saying that first we'll find the module, and if the module is found, we'll add the student to that module. And if the module is not found, then we'll do nothing. So there's no indication at all of error messages or inputs. That's all to do with the solution domain, not the problem domain. When we want to move from the problem to the solution, we can start thinking about the solution domain. And we'll have some architectural decisions to make. What kinds of classes do we need in the solution? Are we going to use model view controller as an architecture? If we are, then are we going to use controllers and services and repositories or some other architectural components? At this stage, again, very little detail, keep it abstract, but we can start to think about the kinds of components that we want and how those components will interact. So let's begin describing the solution. We have described the problem in the use case and activity diagrams. So now we're going to focus on class diagram and sequence diagrams. In the class diagram, one way of working is to focus only on a single use case and then define a class for each architectural component that we will need. And this is where we start to put in a lot of detail. So for each class, we'll need to identify the name of the class, the attributes, in other words, the data that we need to store, including names and data types, the methods, that is, the behavior of the class, including method names, parameters, and return types. Now that involves a lot of detail, and this is the right place to start putting in all that low-level detail. We also need to indicate relationships between classes. What association is there between them? Is there inheritance or implementation of interfaces or dependencies? All of this kind of information will need to go into the UML class diagram. And if you do that for one use case, then you can move on to the next use case. And often the second use case will make use of classes that are written for the first use case. So it might be that we just add a little bit more information to the existing classes. So here's an example diagram. You can see that we've got a lecturer controller and a student controller. Let's look at this just in terms of architecture. We've got two controllers, two services, two repositories. And each of those is labeled according to the actor. So student controller, student service, student repository. And then likewise for the lecturer. The service in this case is not a lecturer service, but a module service. So it's focusing on the kind of functionality that is provided. So the lecturer controller in this example wants to view registered students for a given module ID. Therefore, the lecturer controller will want to talk to the module service to find a module and then get the students on a module, and so on. Now, in terms of the details, let's focus on the module class. I know it's the module class because that first part of the diagram for that class has its name. In the middle section, we've got the list of attributes, including names and data types. And in the lower section, we have the methods with names, parameter lists, and return types. You'll notice also that we have a plus, which means public, and a minus, which means private. We also have an association. This is unidirectional, which is why there's an arrowhead on it. And that tells me that a student controller has a module service, but not the other way around. Module service does not have a reference to a student controller. So we can see here, look, there's the module service attribute. Its data type is module service. This tells me that an instance of student controller will hold in its list of attributes or fields a reference to a module service, and that's what this arrow indicates. So the solid line says there is in the list of attributes a reference to the other object. The dotted line is a dependency, and that tells me that this class is making use of instances of that class, but they're not going to be stored in the student controller fields. Here we've got an aggregation, and that's really just a fancy name for a collection. Module has got a collection of student objects, and that's indicated with this aggregation symbol, and the diamond shape is placed against the class that holds the collection. A UML sequence diagram shows how objects of those classes will interact when the program runs. It's only a snapshot, but it gives us a good idea of how it works. What it focuses on is the sequence of method calls from one object to another in one use case. The sequence diagram will show the order of those method calls. What we have are objects in that diagram with a dotted line from that object, and that is its timeline. And the passage of time flows down the diagram. So higher up the page or higher up the diagram is earlier than lower down the diagram. Let's take a look. Here we have some objects. This is an unnamed object. There is nothing in front of the colon, and then there's the class name. So these are anonymous or unnamed objects. In this example, there is a named object. That's the name of the object and its type. Usually, we will make use of unnamed objects, but it might be helpful to provide a name from time to time just for clarity. These dotted lines are the timelines. So this is earlier in the lifetime of the object than here. That's later in the lifetime of the object. The rectangles are called activations. Essentially, they are the methods. And these lines coming in to the methods are the method calls. This is a call to the method M1. So this is M1. We can see that M1, as it executes, is going to call do this and then do that. When do this is called, we can see that it's going to call do something over in this object. And later on, when do that is called, that will be in the same object as the do something, but it's called at a later time. The actual length of these rectangles is not really significant, but the relative length tells us when they start and finish, relative to the start and finish of other methods. Because this one is called before that one, the starting point of this do something method will be lower down the timeline than the starting point of do this. And the arrow to do something will be after the starting point of do this. So it's all relative. We know that this method will finish after that method because the end point is lower down the timeline. And we can see that this method finishes after all the others. So there's the timeline. This is a method and a method call. This method is called after do something because it's lower down the timeline, and the control of execution will start here on the left, and then we follow the arrow. And in this example, we can see that do this is calling do the other, which is a method in the same class as do this. So that's how we show the method calling another method in the same class or same object. Sometimes it can be useful to show iteration and selection. In this example, we're making use of a loop frame or fragment, depending on your terminology. We can see that it's a loop. Here is the condition that tells us when to iterate and for how long. So in this example, we're going to iterate for each another class object. And therefore, everything that's inside that frame will be part of the iteration and will be done once per iteration. And the border of the frame shows what is part of the loop and what is not. in this frame, it's an alt frame, it illustrates some selection going on. So here is the alt with its condition. So if A is greater than B, what is inside the top section, so above that dotted line, will be executed. And in the lower section, we have the other condition, which in this case is an else. So here's an example sequence diagram. We have in the lecturer controller object a method call to view registered students, which will then at some point call get students on module from the module service. And that method will call find students on module from the module repository. What that will do is iterate, and for each row set, so there's an assumption going on here that there's a database being used, hence the repository. And so what it will do is for each row set, create a new student. We don't show necessarily the return values, although that can be done occasionally. But this is sufficiently clear to show us that when view registered students is called in lecturer controller, this sequence of method calls occurs and involves these other objects. We've summarized fairly quickly some of these UML diagrams, and here's a summary of the summary. We're going to begin by describing the problem domain. What are the use cases that each actor can perform? And we put that into the use case diagram. For each use case, what are the major activities that will take place when that use case is activated? The second step is to make some architectural decisions. Are we going to use MVC? Are we going to use controllers, services, repositories, etc.? Then we can begin to describe the solution, and the class diagram will reflect the architectural decisions made in step 2 and will describe the classes that are needed for each use case, and will in one diagram show all the classes for all the use cases. And then we'll have a separate sequence diagram for each use case to show the sequence of method calls between the various objects in the application. And when we've done all of this thinking and planning, we have a complete solution, and so then we're ready to write the program code based on the design. Because this is just a quick summary, I am sure you'll want to do some background reading about the UML and the diagrams in it.